for example 5 in lesson 5.2. One last proof before you guys head off into homework. And we are trying to prove that cotangent squared of u over 1 plus cosecant u is equal to cotangent times secant u minus tangent u. Okay, so I'm going to set us up like I was yesterday in that cotangent squared u over 1 plus cosecant u. And then my goal is to somehow magically get down to cotangent u times secant u minus tangent u. Okay. With this in mind, trying to decide how I want to go about this. Do you have starter thoughts?
I was thinking maybe start off with my yesterday and multiply by the inverse or conjugate. Yeah, that's what's called.
And that is okay. That's a thought. I'm trying to decide how I would like that idea. It's not what I did. And I think it's a possibility, but I think it's going to...
Well, I'm working on it right now. I'll let you know, I guess.
I am afraid we're going to end up with too much information, or... I don't know. Hold on, let me think for a moment. Maybe I'll like it better than what I did. I don't know. I'm just not sure how it would work. It is a possibility. What's Tinley considering over there?
Because it's like, it's cotangent squared, so isn't that the same as 1 minus cosecant?
Not 1 minus cosecant, but 1 minus cosecant squared. But that is the direction I was going to go. Because then there's some factoring you can do.
Yeah, because then you would just like...
Okay. Now, I'm not saying, Logan, that yours wouldn't work. Because it does have some distinct possibility. I just don't have it worked out in my head. I just don't have it worked out on paper to see how it goes. So it is a possibility.
But I'm getting in there and I really feel like it.
Well, and here's the deal. There's some middle stuff in this one it's tough trying to figure out where to go on some of these. And this is a tougher one. Okay, so if we use the Pythagorean identity, which is the direction I was planning ahead. So on bottom, 1 plus cosecant u stays 1 plus cosecant u. Cotangent u, or cotangent squared. What is the Pythagorean identity we have? We have what? 1 plus 1 plus cotangent squared u equals cosecant squared u. So if you subtract 1, cotangent squared is cosecant squared minus 1, right? So let's try this. Cosecant squared u minus 1 is my new numerator. Okay? Now, what could I do with that numerator?
You can factor out.
Okay.
Does it actually equal cosecant u plus 1 and cosecant u minus 1?
Okay. So,
yeah.
Pick a close seat.
Glasses are needed.
Okay. So cosecant squared u. This is kind of just like factoring, for instance, if you're factoring x squared minus 1, right? This is like factoring x plus 1 and x minus 1. So cosecant squared u minus 1 would be like factoring cosecant u plus 1 times cosecant u minus 1 all over 1 plus cosecant u.
So those cosecant u plus 1 in the denominator can cancel out.
Okay. One of my factors is cosecant u plus 1. My denominator is 1 plus cosecant u. Are those the same? They are. I almost rewrote the denominator the other way, but you need to be able to realize that this factor can cancel with my denominator, leaving me with cosecant u minus 1. Okay? Now, I don't know. As I look back through mine, I'm not convinced I've done this in the best order, so.
Yeah, and actually they were wrong, and that's the right answer.
And then we're just done is what you want to be?
Yep.
I wish. Okay. We no longer have a Pythagorean identity because we don't have a squared. Okay. We could talk about in terms of putting these together, but in order to do that, we have to get a little bit farther. One of our options is turning things into sines and cosines, yes? Okay, so what is cosecant in terms of that?
It'd be 1 over sine u minus 1.
Okay. Now, I'm going to do something a little differently with the 1, though. The cosecant is 1 over sine u, correct? Now,
Get a common denominator.
if I leave it as minus 1 right here, I can't really do anything with it. If we start talking common denominator, we already have a denominator of sine, so a common denominator would be sine, correct? What is 1 with a denominator of sine?
It's just sine u over sine u.
Sine over sine. It's kind of like me asking what's 1 with a denominator of 5? Well, that's 5 over 5, right? Or 1 is x over x. Or in this case, I'm going to say it is sine u over sine u. The reason I did that is the first one turned to 1 over sine. Then this one, I'm trying to go for that common denominator idea. Because now I can take these two and put them together, yes? Common denominator of sine u, what's going to be on top?
1 minus sine u.
1 minus sine u. Now, this is where we stop to see what we have besides a mess. And okay. How do I want to say this? This is where I'm going to pause and I'm going to look at my answer. Okay? My answer has a cotangent out in front and then parentheses a secant minus tangent, right? What do you know about cotangent?
Equal cosine over sine.
Okay, is that a true fact? Cotangent is cosine over sine, right? I have a sine here. I have several sines in my problem, but I specifically have a sine in my denominator. Do I have any cosines?
No.
Do I have a way to really get any cosines with what I currently have?
No.
I don't. So yesterday, one of my ideas was multiplying by the conjugate. And remember, as long as you multiply top and bottom by the same thing, it's legal. Okay? Well, I'm looking at the fact that I don't have any cosines. And I know I'm going to need a cosine in the denominator for a cotangent. Excuse me, a cosine in the numerator. So an option we have here is to multiply top and bottom by cosine. Now, hear me out, okay? Because by doing this, eventually what I see is I don't have any cosines in the problem. I'm going to have a cosine on top and a sine on bottom. that I'm going to be able to put together as my cotangent. My hope is the rest of this stuff will work out to be what I need it to be. Does that make sense? Okay. Like, the hope is that this other stuff will just kind of sort itself out. Okay. So, I'm going to rewrite now. On top, I'm going to put the cosine out front and just put it, and then leave the 1 minus sine u in parentheses. Cosine u times 1 minus sine u. Okay? Are those the two pieces multiplied together? Right? On bottom, I have sine u times cosine u. Officially, I would say it doesn't matter which order I put those in, does it? But I'm trying to give you a visual. So I'm going to put the sine first and then the cosine. So I'm going to say that it's sine u times cosine u. What do you see out front right now?
Okay.
There's a cosine over a sine, yes? And keep in mind, how do we get fractions when multiplying? You just multiply the stuff together, right? So in that same sense, you can just separate. We can't do that with adding, but we can with multiplying. So I'm going to separate this into two fractions. The first of which is cosine u over sine u. Times, what are my other pieces remaining? 1 minus sine u over cosine u. Now, pause for a moment. Is this an equivalent statement?
Yeah.
On top it was cosine times 1 minus sine. I still have that on top, cosine times 1 minus sine. On bottom it was sine times cosine. I still have sine times cosine. I just rearranged things. Okay? Now, cosine over sine. Do you want me to go ahead and switch it? What do you know about cosine u over sine u? That's cotangent u, yes? Almost there. Now, we have 1 minus sine u over cosine u. I want to split this into two fractions.
Separate the numerator.
Okay. My common denominator is going to be cosine u, yes? And then what are we going to have? We're going to have 1 over cosine u minus sine u over cosine u. And again, this is like separating a fraction. That's one of our 5 things. We just don't do it very often. We don't usually have to separate a fraction, but if you have a single denominator, make it the denominator of both pieces. What's my next step?
Your answer.
Are we there?
Yeah.
Yeah. Cotangent u, we already has cotangent u. 1 over cosine u is secant u. Sine u over cosine u is tangent u. Okay? That's a tougher problem.
I just
Okay.
don't think I'm ever going to get to the multiplying by the cosine.
Yeah, just pulling something out of nowhere.
And that's, I agree. And it's one of those looking for what's missing. I don't feel like you have to do that crazy often where you're just multiplying by something randomly. The idea of multiplying by a conjugate like we did yesterday, I think is what you would see more often. Okay. Again, that's not one of the steps you see a ton in homework, but it is there.
Yeah, do the most is like going from like cosecant minus 1 to the 1 over sine u.
Right. And that's, as I said, there's some tough stuff.
Yeah, I don't think
Not all the problems are going to be like this, though. Okay? This is, to me, like the top end tough. Okay? Now, your homework. 12 through 39 multiples of 3 is still what the homework is. However, as it was put yesterday, we have to do math to figure out our math assignment. It's multiples of 3. You guys have been doing multiples of 3 since like kindergarten or something, but
Well, it sounds like the upcoming elementary kids haven't been.
Yeah.
okay, well, so-
Oh, yeah, Miss Coke.
multiples of 3, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39.
That's like.
I wrote them out so you have them. Now, tomorrow is a work day for those of you that are here. Those of you that aren't here, either way, it's due Thursday. Thursday we'll plan to go over questions so I can help you get some of your pieces filled in. The homework is due by the end of the period. Okay? And I say just do it at the end of the period because we'll go over questions first before we turn it in. And remember, I am grading this homework and checking the work. Woo.